Okay, so welcome again to our AQA GCSE Physics Specification course that I'm doing with you. In today's lesson we're going to be looking at electrical charges and the fields that surround them. Okay, so there are two types of charges in the universe, okay, for GCSE that you need to know. One, okay, we can have one category charge is a positive charge, okay, and we've got multiple examples of these. The most common one is the proton in the nucleus, okay, so it's got a positive charge. Then we also can have negative charges. And the most common example of this is the electron, okay, on the outside of your atom. Now, obviously I've drawn them the same size. In real life, the electron's approximately 1800 times smaller and lighter than the nucleus and the protons in them, okay? So this is not to scale, okay? So bear that in mind. However, in terms of their charge relative to one another, if a proton is +1, an electron will be -1, okay? And if there's one proton and one electron, the total charge is 0 or neutral, okay? Now, I'm now going to draw the respective field lines that you would see around these charges. Now, field lines will always be the direction a test positive charge would move in. So let me explain. If I put another positive charge here, it would move in the direction of this red arrow, okay? Likewise here. It would go downwards, here, it would go that way. If I now change my charge so that this is now an electron, the field lines would go into it like this. Okay, because if I now put a test positive charge in these locations, they would be attracted towards the negative charge. So several things to note down here. Opposites attract. Okay, so make sure you can recall this in your exam. Okay, which means like charges will repel. So these two positive charges will repel, as well as two negative charges. However, if I have two opposite charges, they will indeed be attracted to one another. Okay? So, you need to remember those points for your exam. One other thing. And again, you can pause this video if I'm going too fast. Take screenshots of any of the drawings that I'm doing. Is the definition of a field or an electric field. Okay, so this is a region of space where a charged particle experiences force. Okay, and this brings us to the concept of electrostatics, or the electrostatic force. Okay, you may have done this at a party, blown up a balloon, rubbed it against your hair, and if the humidity is right, that balloon may stick on a wall. Okay, and the physics of that is due to the fact that we have electrons moving from one surface to another, so either from your hair to the balloon or vice versa, and that basically results in a difference in electrostatic charge. And as we've said, if opposites attract, so for instance, here's my balloon and here's my wall. If my balloon as an excess positive charge because we've taken some electrons from it when we've rubbed our hair onto it. As this balloon moves towards the wall, what's it going to actually do? It's actually going to move some of the electrons that would have been here closer to the edge in that direction. Okay? Oh, sorry. Opposite's going to happen. It's actually going to cause electrons from this side of the wall to be moved this direction so that we get an electrostatic force there. Okay? So that's how a balloon can stick onto the wall. The opposite can happen as well. If the balloon had negative charges here, what I drew initially would take place. So we would have negative electrons being pushed that way, and we would have your positive protons staying put, and we would get an electrostatic force there. Okay? A lot of students ask me the question, how do we know which surface has the electrons being removed and which surface has the electrons being transferred onto them? We actually don't know, okay? But in your exams, the only charged particle that gets transferred are the negative electrons. So in the exam question, if it says surface A becomes negatively charged, you know the electrons are being transferred from another surface to that surface, and vice versa. Okay? So if it was positively charged, electrons have been removed. Okay? So the only charged particle that can be moved between two surfaces due to rubbing is the electron. Why is that? Because it's located on the outside of the atom, and it's also a lot lighter than the protons. It takes a huge amount of energy to remove a proton from the nucleus. Okay, hopefully that's helpful, and all the best in your exams.